We are solving the problem 1718, construct the lexicographically largest valid sequence. So we're given an integer n and we have to find the sequence that satisfies all of the following. So integer 1 should occur once, each integer between 2 and n should occur twice, and for every integer I between 2 and n, the distance between two occurrences of that I must be exactly I. And we have to return the lexicographically largest sequence. So you can try to come up with a greedy solution, but that's not going to work. And if you look at the constraints, n is at max 20, so we can afford a exponential time solution for that. And this can be solved using backtracking, where we try to, for each index I, we try to insert the largest value first, and then try to find if we can get a solution with that. So for the initial array, let's let the length be m, and m is going to be equal to 2 times n minus 1 plus 1, and we can define that array as arr and initialize it to minus 1. We also need to track the elements that we have already been to, so we can define a set for that, and then we can define our backtrack function. This takes an index I, so I is the value where I is the index where we want to insert the value. So if I is equal to m, that means we reach the end and we can just return true. Then as we're inserting in the decreasing order, we have to consider we can only insert if the value is not equal to value of index I is not equal to minus 1, because minus 1 is the default value, right? So if arr of I is not equal to minus 1, uh, so that means that the array and that the value is already filled and you need to check the next index. So you can just return backtrack of I plus 1. Now we can run a for for num in range n to 0 minus 1. So this is going to go from n to 1. And if number is number in scene, so we have already visited it, we can just continue. Else if num is equal to 1 and if it's not equal to 1, so there are two cases here. So if number is 1, we can add it only one time in the array. So that means arr of I is gonna be equal to 1. Then we can add 1 to our scene set, and then we can backtrack with I plus 1. So we can add num, sorry, and if this backtrack is successful, we can just return true. After backtracking, you have to remove the elements. So scene dot remove num, as well as we have to reset the array position. So we put it to minus 1. Similarly, when num is not equal to 1, we have to add them twice. So before adding them twice, we have to check the indices and make sure that we don't get an index out of bound error. So if I plus m, I'm sorry, if I plus num is less than n, and um, if the second value that you're going to insert it's equal to minus 1, then like if it's equal, then only you can insert it. So if arr of I plus num is equal to minus 1, you can insert both the values. So arr of I is equal to arr of I plus num equal to num, and scene dot add num. Then we can backtrack it. If backtrack of I plus 1 is true, we can return true. After that, we have to remove the values, and similarly arr of I to arr of I plus num equal to minus 1. And that should be good. After the for loop, you can just return false, unsuccessful, but we don't really need return condition. We just need the value of the array, which is going to be modified in place. So here you can backtrack with index 0 and return array. And this looks good enough. Let's try to submit. Okay, let's give it a submit. Alright, there you go. It should be exponential time 2x run. There you go. See you tomorrow.